Okay, so we're going to look at the alternating series. Alternating series is one of the more popular series tests that we need to be familiar with. It just kind of sounds like what you think it would be. It's a kind of series that alternates. Well, I would consider this one alternating. Why? Well, without the -1 in front, it's just 1 over n, and we should all be okay with that. That's our harmonic series, or a p series that diverges. However, if we add in this alternating positive -1, we can show that it actually does converge using the alternating series. So this one is clearly an alternating series here. Why? Because without it, it would just be a bunch of positive numbers, right, going from 1 out to infinity. Excuse me, to a very small number, 1 plus a half plus a third, la da da. But if I put this negative here, it's going to be, when I plug this in, I get 1 minus a half plus a third minus a quarter, dot, 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 dot. Right, so that feels very alternating, right? Same kind of thing here. This is alternating slash geometric. It's kind of a hybrid here. This n is really throwing me off here. If I just plug in some numbers here, plug in 1, this denominator goes away, it's just going to be 1. If I plug in 2, I'm going to get -2, so it's going to be 2 over -2. And then if I plug in 3, this is going to be 3, and then this is going to be 3 minus 2, which is 4, and then minus, if I plug in 4, this is going to be 4 over. This is going to be -2 to the third, which is 8. That's why the minus there is from the negative. So that's pretty clearly alternating back and forth. And is this one alternating? Yeah, sure. That's because, not so much because of the 1 over n, because notice here that I have this coefficient here of 2n minus 1. That generates any odd number. So let's just look at that. Let's just plug in 1. I get 1 over 1 from this guy in front. If I plug in 1 here, I get a half. Excuse me, so I get the sine of pi over 2, plus if I plug in 2, I get a half, and then the sine, if I plug in 2 here, I get 3 halves pi, plus, and if I plug in 3, I get a third, the sine of 5 pi over 2. So this thing right here is just going to be 1. This is -1, so it's going to be half. This is going to be +1, so it's a third. I feel like the next one's going to be a quarter. I don't feel like doing it. Is that alternating? Yeah, it's going from positive, negative, and hopefully we can do something about that. And we can, and we'll go through some of those problems here. So there's a couple things that we need to check for alternating series. The first thing we need to do is show that my limit goes to 0. If it doesn't go to 0, then we can probably just go back and use the nth term test or the divergence test. The other thing we need to show is that your series is decreasing, and we've already discussed that, so that should be okay. And then the last thing we need to consider ourselves is converges absolutely or converges conditionally. And we'll talk about those two right there, but let's just briefly talk about it right here. This thing right here is absolutely converges because we don't really need that -1 to make it converge. Why not? Well, because this thing all by itself, this 1 over 2 to the n minus 1, that's a converged geometric series. This -1 isn't going to help it converge make it converge faster, but it'll still converge with or without that -1. Conditionally convergent, this is the classic conditionally convergent, and we'll look at that in a minute. Why is that? Well, because this guy right here, the p series or the harmonic series with p is equal to 1 diverges. However, if we add in this -1, it will converge. Why is that? Well, looking back up here, notice here, I feel like this is going to converge with these alternating signs because it's going to make this series, the sum of this series, be more manageable with these alternating signs, with these positive and negative terms. So without these alternating terms, this series diverges, right? Because 1 over n diverges by the harmonic p series. If we add some alternating ones, it'll converge for us. So that's the gist of alternating series. We'll do some practice problems, and we should be fine.